this video, we're going to discuss a couple different situations that happen in a probability type of problem. And they're related to each other, but there's a subtle difference. So part of this is going to depend on how well you can read and interpret the problem before you even worry about the math. Okay? If you look at this first one, it says if one card is randomly drawn from a standard deck of 52 cards, that means no jokers are going to be in there. What is the probability that the card is a king or a queen? Now there's a distinct word in here you have to be able to recognize. Or. Now when this word shows up, it doesn't always mean it's this type of problem. But I hope after this video you can at least see the type of problem we're looking at. And what I mean by that is this problem is asking us to draw one card. So there is one thing we're looking for. One card we're drawing out. Okay, we're only going to take one. We're not taking 2 or 3 or 4 of them in a row. It's just going to be one card, and it has 2 options. It can be a king, or it could be a queen. What we would like to know is, what are the chances of that happening? So we think to ourselves, how many kings are in a deck of cards? Well, there's 4 of them, one of each suit. And there's a total of 52 cards. So if we were just trying to draw a king, we'd have to take 4 divided by 52 to see what sort of chance there is that that would happen. But this says it could be a king or a queen, so that gives us more possibilities. It could also be a queen, which means there's another chance. There's basically 4 more cards within that deck, gives us better odds. So I could have a king or a queen. And when we are dealing with or type problems, we're going to be adding these probabilities because they both kind of contribute to the odds of us being able to draw one of these cards. So when I put those together, I get 8 out of 52, which is 0.154. And sometimes these decimals don't mean a lot to people. What that really means is there's a 15.4% chance that if I draw one card from a deck of cards, it's going to be a king or a queen. Now, as you look at the second part of this problem, it seems like it's pretty much asking the same thing, but there is a subtle difference you have to recognize. It says, what is the probability that the one card you pick out is a heart or an even number? Now, it seems just like the first one we did, but there's a difference that I really struggle to get people to recognize the first time they read a problem like this. If you look back at our king and queen problem, and this is hard to put into words, but it's called mutually exclusive events. What that means is there are no kings that are also queens. And that sounds pretty stupid, but it's what this is really saying. If I pull out a card that's a king, it's not also a queen. Those are completely different cards. When I look at the heart and even number, if I know enough about basic cards, there are some hearts that are also even numbers. So there's some overlap here. Some cards could be in both categories. So how do we deal with that in terms of probability? Let's set this up, and we'll start by listing all of our options. I'll use what's called a Venn diagram because this is a nice way of kind of laying out all the possibilities. In this left circle, I'm going to put all of the hearts. And in the right circle, I'm going to put all of the even cards. And just see how many there are. Sometimes it's hard to keep track of it in your mind. So if I take a look at the hearts, in every deck of cards, there's 2 of hearts, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and an ace. There's one card of each type that happens to be a heart, of each number. So it looks like I have a total of 13 hearts. Now if I look over my evens, it's a little tougher to do because there's a lot of them. Let's think about even numbered cards. Even number. That is kind of a big deal. Those of you who play poker, you know that certain face cards are worth certain amounts. We're just going to worry about even numbers. So if I look at this list I'm going to create, I have 4 cards, one of each suit, that are all 2s. I have 4 4s, 4 6s, 4 8s, 4 10s. So that's a total of 4, 8, 12, 16, 20 even cards. Now the problem is we can't just set it up like this problem here because some of these cards ended up in both groups and we can't count them twice. We can only count them one time. We don't want to mislead ourselves into thinking there's a greater probability because we're counting the same card 2 times because it ends up in both groups. So we need to find the overlap. The overlap means which cards come from both categories. Now let's look at this. We've got 4 2s, but one of those 2s is a 2 of hearts. So the 2 of hearts is over here, and it's also in that group. We can only count it one time. We also have the 4 of hearts, the 6 of hearts, the 8 of hearts, and the 10 of hearts. Those numbers show up once in each of these, but they also show up in this group. So the way we set this up is we kind of pretend it was the previous problem. We're going to take a look at our hearts. There are 52 cards, and it looks like we have 13 of those that are hearts. Okay, so there's my hearts. We're going to add in how many even cards we have. 20 out of 52. Those are my evens. But then we have to subtract anything that was counted double, that was counted twice by accident. So we're going to subtract what I call the overlap. And the overlap in this case is right here. There are 5 cards that got accidentally counted twice. So I'm going to subtract those. And then because I know a little bit about fractions, I can take 13 plus 20, which is 33, minus 5 gives me 28 out of 52. If I want, I could put that into a calculator and get a decimal, or I could reduce it. Either way, it still means the same thing. This is the probability, and it's very important you can recognize when that exists. So, once again, the first problem we had, we call that mutually exclusive events, meaning a king and a queen have no overlap. They are one or the other. Down here, it's not that way. There's a little bit of gray area because we have some cards that could count in both groups.